Here's some more examples of chain rule. We're using color for emphasis, and we're going to go express here. We're not going to write out f of g of h of x. We're just going to use color to show the composition and then do the derivatives directly. So the first example is a composition of two functions. The outer function is the square root and the inner function is the polynomial. So we'll write it in exponent notation because that's easier to take the derivative. And now we're just going to take the derivatives. So we start with the derivative of the outer function, 1/2 times something to the negative 1/2. That something is the same, doesn't change, but then we multiply it by the derivative of the inner function. And we can simplify this by moving the negative exponent down to the denominator, and we can simplify it further by dividing 6 and 2, and then we can also return it to the original form in which it was presented by putting it back in radical. So that would be the simplest form of our derivative. Another example. Here we have another composite function. This is a composition of three functions. We have cosine of something, we have something cubed, and we have the polynomial function of x. So let's rewrite it again to show that we're taking the cosine of something and then that entire cosine is being cubed, so that the raised to the third power is our outermost function. Now when we take the derivative, we're going to start with that. 3 times something squared, that something doesn't change. The chain rule lets us go now to the next inner function, which is cosine. The derivative of that is negative sine, but what's inside cosine doesn't change, it stays for what's inside sine. And then we take the derivative of the innermost function. Remember to keep the parentheses, otherwise your expression has a different meaning. If we wanted to simplify this, we can just move all of the numeric factors, the 3 and the negative symbol, and the 4 minus 2x polynomial factor to the front, and then the trig factors. Convention just has us simplify that way. And if you did this on a calculator and you wanted to check it, you might see that it started with -6 because it's going to factor a 2 out of that first polynomial factor. So you might see it this way too. And that could be a simplest form. Another example. Here it looks like we might have a composition of, does it look like 2 or 3 functions to you? Okay, well it is actually 2 functions. If we write it as 3 times something to the -2, then our outermost function is that, and our innermost function is the polynomial. Then we can take the derivative, first by doing the outer function, and with respect to the inner function, so that doesn't change, but in this step we use the derivative of the inner function. And we can simplify that to get -6 in the numerator, polynomial expression in the numerator, and the cube in the denominator. Another example. This is a sum of terms. So if we take the derivative of each piece, we don't have to worry about them interfering with each other. This is not a composition, this is just a polynomial term. The next one is also not a composition, but we're going to write it in power notation so it's easier to take the derivative. The third term is a composition. It's a composition of 3 functions. We have something squared, then we have the sine of something, and then we have pi x as our innermost function. So let's take the derivative. Derivative of 3x squared we can take, the derivative of x to -2 we can take, and now we need chain rule. First we take the derivative of the outer function without changing the inner function. Then we take the derivative of the next inner function without changing the innermost function, and finally we get the derivative of the innermost function. Simplified, there's not a whole lot to do here. If we get rid of the negative exponent, we can put the second term in that form, and then really all we can do here is move the pi to the front to combine it, so we can get rid of one set of parentheses that way, and that's our simplest form. Here are some examples to watch out for that are a little deceiving at first glance, so let's look at them. The derivative of this is, hopefully you see, just 3. Sine of pi halves is a number. You should know the number, but in any case, even if you don't know the number, you just know that it is a number and that the derivative of it is just going to be 0. So that simplifies down to that derivative. What about this one? This one is definitely a composition. It's the sine of the cosine of x squared, and if you practice chain rule, you'll see that you'll get this as the result. So you should verify that for yourself. What about this one? This is not a composite function. This is just cosine of 2, which is just a number, times x cubed. So we can just take the derivative of that using the power rule. Whether you write 3 times cosine 2 times x squared or cosine of 2 times 3 times x squared, doesn't matter. Same thing. What about this one? It looks just like the one above it, so shouldn't it be just 3 times cosine of pi halves times x squared? Well, yeah, but it also could be 0. So if you look carefully, you'll see that cosine of pi halves is a number. What number is that? So that will explain that to you. If you simplify things before you take the derivative, sometimes you can save yourself taking complicated derivatives unnecessarily. This last one, okay, cosine of 0 is a number, but why did it just go away altogether? Well, because cosine of 0 is 1, so we can just simplify it without it being there. So those are some ways that you can just make sure you're thinking about what you're doing before you go through it procedurally and make sure it makes sense. I hope these were helpful. Thank you for watching.